Hi everyone, in today's video we will be determining the closed loop transfer function by using the block diagram techniques. So looking at this diagram, looking at this system, we want to resolve these blocks to become one. And what is our first challenge? What is our first challenge in this system? As you can see, this system is different. We are having three signals in this system: plus, plus, and minus. So whenever we are dealing with three signals, or whenever you are given any diagram, whether that diagram is complex or not, the very moment you see three signals, the first thing that should come into your mind is splitting the summing point. So we are going to split this summing point. We are going to make them to become two. So the first step, step one, we say splitting the summing point. Splitting the summing point. So look at how we'll do it now. We have a row of x. So we have this. This is the first summing point. We have G1 and we have plus plus. So now I'm splitting this summing point now. We have plus plus here, and over here we would have plus minus. So these are what? This is our G2. So this is our C of x. And down here we have H2. We have H2. So this is it. I'm redrawing back the system. And over here we have H1 connected to this. So now we have splitted the what? We have splitted the summing points. So the next step we are going to do is to solve the negative feedback. You see, splitting this summing point has enabled us to know how we can be able to resolve this immediately. So the next step we are going to do is to solve the negative feedback. So we say step 2. Step 2, we say solving negative feedback. So what we are going to do now is to resolve this. So we redraw this system. We say a row of x plus minus G1 plus plus G2 all over. So we are resolving this now. What we have is using this formula, because it is a negative feedback transfer function. So we will use this formula G all over 1 plus GH. So we say G2 all over what? G2 all over 1 plus G2 H2. So this is what we get. And here we have H2. And we connect it over to this. So here you have C of x. So now looking at this, we have resolved this first step. We've resolved this first step. And the next thing we are going to do is we are going to shift this summing point after the block. This particular summing point, we are going to move it to come after the block. And remember, according to rule number 10, whenever you shift a summing point beyond or after a block, you would do what? You would add the actual gain of that feedback. So we are adding the actual gain G1. So we say step 3. Step 3. We say shifting summing point after the block G1. So let's redraw this. We have a row of X. So we'll put our G1 over here. This is our G1. Then we put plus minus. Then plus plus. Then G2 all over 1 plus G2 H2. So here we have C of X. So we move this over here. We have moving this over here. We have what? H1. As you can remember, we moved this summing point. We moved this summing point to come after G1. To come after G1. So we'll be adding the actual gain. So the actual gain we'll be adding is what? G1. Okay. So here we have this over here. So that's good. So now we can now be able, the next step we are going to do, in order for us to resolve this in particular now, in order for us to resolve this area now, the next step we are going to do is to rearrange the summing points, or we can say exchange the summing point. So what I want to do now is carrying this particular summing point, I want to move it over here, and this one I want to move it over to this place. So looking at the next step we say step 4. Step 4, I say exchanging summing points and multiplying gains. Multiplying gains of block in series. So it will enable us to so what the next step we are going to do is, after we exchange these two summing points, we would also do what? We would also multiply G1 and H1, these gains. We will multiply them because they are in series. So next we are going to have, the diagram would be like this. So we have a row of X. Here we have G1, and here we have plus, plus. So I'm rearranging it now. So we have plus, plus, and here now we have plus, minus. So this is what? Our G2 all over 1 plus G2H2. So here we have C of X, and over here, so provided we have multiplied this in series, this G1 and H1, we've multiplied them, so we have G1, H1, so we connect it over to this place. So remember, because we have interchanged, this arrow now will go over to this place and come over here. So this is how the diagram would look like. So now we can now be able to resolve this. We can now be able to resolve this. So it won't be a problem to us. So the next thing we are going to do is putting it in this order. We have a row of X, G1, plus plus, So we have, so using the formula for negative feedback, because you see this arrow is going in, is passing through what's a negative feedback. So using the formula we have G2 all over 1 plus G2 H2 all over 1 plus G2 all over 1 plus G2 H2 times this our G1 H1 now. We are going to, is now replaced as what? H. We're going to call this H. So we have G1 H1. So this is what C of X. So the next thing we are going to do, we enter to step 6. So step 6, we are going to now modify this block. We will now modify this block. This is a particular. So what we'll be having is, okay, what I want to do first of all, before we do this, what I want to actually do now is, we are going to, this particular block now, we are going to take the LCM so that it will not be so cumbersome for us. So we are going to say, resolving this block now, we say G2 all over 1 plus G2H2 all over 1 plus G2 all over 1 plus G2H2 times what? G1H1. So what I want to do is, first of all, we are going to take the LCM of this. So we take the LCM of this. So taking the LCM, we have 1 plus G2, G1, H1 all over 1 plus G2, H2. So collecting the LCM, we have, using this denominator, 1 plus G2, H2. So this divided by this times 1, we have 1 plus G2, H2 plus this divided by this 1 times this, we have G2, G1, H1. I'm just taking my time to do this for those that may not know how to resolve this. So what I'm now going to do is, we would carry this now and input it, replace it with this. We will carry this and replace it with this. So rewriting it, I'll have G2 all over 1 plus G2H2 all over 1 plus G2H2 plus G2G1H1 all over 1 plus G2H2. So the answer will, so what we are going to get is, taking the reciprocal, we have G2 all over 1 plus G2H2 times 1 plus G2H2 all over 1 plus G2H2 plus G2G1H1. So this will cancel this. So we are left with what? We are left with G2 all over what? 1 plus G2H2 plus G2G1H1. So this now, we are going to now, we have now modified this particular block. So in step 6 now, we'll now say, in step 6, we want to now resolve this. Resolving this block now. This is the block we want to resolve now. So resolving this block, we will now have arrow of x. Arrow of x, we would have 1 plus G1. Then we will now fit in this our block. This one now we have over here. We we now have G2 all over 1 plus G2 H2 plus G2 G1 H1. So this is it. So this will be our C of X. So now what we now do next is we are going to, because they are in series, we are going to multiply them. So we have a row of X, so we have, multiplying them, we'll have 1 plus G1, G2 all over 1 plus G2, H2 plus G2, G1, H1. So C of X. So our transfer function C of X all over a row of X is this, is equals to 1 plus G1, G2 all over 1 plus G2, H2 plus G2, G1, H1. So this is our transfer function. Or you can say the overall transfer function C of X, it can be given as G2X plus G1X, G2X all over 1 plus G2X, H2X plus G1 S dot G2X. So this is our answer. So whatsoever you can put it in this link. So thank you very much.